All right. Yeah. So that whole like 3 or 4 minutes, because I had started taking attendance maybe a minute or so before 9, and then it was just like the floodgates open. I was like, man, it was just so many students. So it just took me a while to kind of get through the list today, but that's all good in the neighborhood. I think you guys know how to find it. The contact info for Dr. Lamar, the facilitator of the lab. But yeah, you would have to basically go on Blackboard on the left-hand panel. It's going to say Online Alex Lab. You click on that, and that's where her contact info will be. Or you can even go to like the Morehouse website, or you can call to the school and go call to the math department and ask for Dr. Lamar, Tawana Lamar, and those are some of the ways. But her stuff is I don't know it, but that's what you would have to do. Okay. Let me start here. Let me check Zoom one more time, to be honest. Oh, see, that's why I said that. Let's share my screen. It's kind of hard for you guys to see my screen if I don't share it. Go ahead and get this student. We'll start here. Okay. I hope everyone is doing well. I do feel like I need to kind of go through my attendance and do an alert for people that have been MIA. I probably just dropped I'll probably ask my advisor, like, hey, do you want me to just put in a motion to drop these people? So, because at one institution I was at, I could drop somebody at this stage, and then if they were like, hey, I was just trying to stay in, we could easily add them back. I'm just going to confirm, as long as you've been coming and you begin your attendance credit on a daily, you can see your attendance status on Blackboard. But I do need to kind of sit through and go through and weed out some names, because there are some names I've noticed I have not seen in quite a while. And that's a huge, huge red flag. So that's neither here nor there. As long as you've been showing up, you've been making your way into the Zoom at each of our sessions, you're good to go. Again, you guys have a lab, so as long as you've been kind of doing your lab, that's for the lab component, which is 10% of your overall grade. Our portion meets on Mondays and Wednesdays. The lab is whatever time you schedule it for, whatever time works for you, So, and the only real announcement that we have is that this is the end of week 11. So that means, matter of fact, I think let me see if I can check it right now. What time did I schedule? Take a look here. Where is it? If I click here, if I go to manage, so if I go down to week 11, it's 7-10, week 12, right? Yeah, the 31st, I guess that's Monday. I think I meant to do that. I guess that's fine. I probably should have did the 30th. Just checking a calendar real quick. Monday. Yeah, that's kind of a pain to go through and change those. And then I have it due on the 6th. Why don't I do the 31st? All right, I'm gonna go ahead and change it to make it available on Sunday, the 30th, and it's just a start date. I was off by one day. Let's see. Let me change the date and assign status. Screw. The reason it's a pain is not this edit, it's because I need to go through all my classes and make that change. You gotta make that change. All right, so let's just go ahead and do it, at least for you guys. Let's see, update all settings. Okay, so it should become available this upcoming Sunday. Let me check one more time. Okay. So your exam 3 covering sections 2-1 to 2-3, 2-1, 2-2, and 2-3 should become available this upcoming Sunday, starting at 11:11 a.m. and it'll be due the following Sunday, which is the 6th at 11:59 p.m., right? I don't want to cheat you out of a day. That's why I was like, I want you to have as much time as you can to maximize that score. So I do need to go and do that for my other students, but I don't want to eat into you guys' time, so I'll do that a little bit later, hopefully. I should remember. All right. So let's kind of get into get through as many of these questions as we can. We're asked to use synthetic division to find the quotient and the remainder when the first polynomial is divided by the second. Okay, synthetic division. So let me see. Let me get a copy of this guy. And again, so it's our usual spiel. I'll check attendance again at around the 15-minute mark. Let me just go ahead and get a copy of this. So this comes from section 2.3. This is question number 1 from the back of that section. Okay, that's good about there. All right. Let's take this. Right. All right. And we're just going to get started here. Okay. This guy also sucks. All right, so synthetic division, right? So the first thing for synthetic division, we have to be dividing by a linear binomial, and we are. So then the next thing is we need to make sure that every power is accounted for, right? It looks like every power is accounted for, so we don't need any placeholders. Then when we go to put a number in the chair, the 0 of the linear binomial goes in the chair, right? So the 0 of this guy is 2. So we put 2 in the chair, and then we take our coefficients. In this case, it's going to be 1, 2, -7, 1, -1, and 1, right? We started with the degree 5. That means we should have 6 numbers. 1, 2, 3, 4, 5, 6. Okay? So now when we go to do synthetic division, the first number just comes down. Okay? And then on the diagonal, we multiply. So 2 times 1 is 2. Vertically, we add. Okay? So then that's 4 times 2 is 8. That's 1, 2, 3, 6, 5, 10, 11. Okay, this is our remainder. Okay, the quotient and the remainder. Okay, so if we started with the degree 5, that means at this stage we're at a degree 4. So we have x to the power 4 plus 4x cubed plus x squared plus x plus 5. And our remainder is 11. Okay. So then we want to hop back to Pearson and type this in. So for something like this, I'm going to do my split screen so I can see my result along with the necessary information over here. Let's turn this off. Okay, I think we're okay. Okay, cool. So then we have x to the power of 4. Let's see, can I? Okay, this one. Plus 4x cubed, so plus 4x to the power of 3 plus x squared plus 3x plus 5, okay? And the remainder is 11. Come on. Okay. Check the answer. Let's go ahead and do one more, then I'll check attendance. Synthetic division to find the quotient and the remainder. I guess I could at least screenshot. It's a little bit weird. You know what? I'm gonna scrap this. Delete. Let's go like this. That's better. Okay. Just gonna drop this here and give it a go. That should be good about there. Okay. Synthetic division to find the quotient and remainder. Let's see. All right, so notice we're missing some of the power, so we need some placeholders. We're gonna need some placeholders here. Into the chair, we're gonna put -2, okay? And then we start writing our coefficients. So we have 1. Now power of 5 is missing, so we need a placeholder there. 4 is 4. Power of 3 is -1. Power of 2 is missing. Power of 1 is missing. And the power of 0 is 6. All right. We started with the degree 6. So that means we should have 7 numbers. 1, 2, 3, 4, 5, 6, 7. Okay. Without those placeholders, we would be led astray. Okay. So let's go ahead and do this one quickly. The 1 comes down. -2, -2, 4, 8, -16, -17. Is that 34? 34, 68, -68. 120 plus 16, 136. 142. Okay. Let's see. We started with degree 6, so at this point it should be a degree 5, 4, 3, 2, 1, and 0. Okay. Submit this one, and then I'll check Zoom. So then. I think this might be a little bit better. Maybe not. Well, here, I'm just typing it in, so no. Let's go like this. Okay. So let's see. X to the power of 5 minus 2x to the 4, 2x to the power of 4, plus 8x cubed plus 8x to the power of 3, 17x squared, x to the power of 2, 34x, okay, minus 68. Do not factor, use quotient and the remainder. The quotient is, okay, let's hit enter. And the remainder is 142. Okay. All right, now I'm going to suppress this. And I'm going to check on Zoom really quickly. I think he was here already. Check my attendance. Yeah, he was here. Okay, that's fine. All right. Let's look at this one. Use synthetic division to find the quotient and the remainder when this polynomial is divided by this guy. Anybody feel confident in giving this one a go? Okay. Like this. All right, so I feel like I should do some kind of oral exam. I'm totally being lazy. I'm totally being lazy. There's at least 2 opportunities for me to make that a part of the class, or I could take a day or 2 to just do that. And I think I might do that because we have some extra time. We'll see. It's all based on just me, really, because I need to hear from you guys. All right, but that's neither here nor there. Okay, use synthetic division to find the quotient and the remainder when this is divided by this. Okay, so if we're dividing by x minus a half, that means 1/2 goes 1/2 goes in our chair. Okay, then we have 2 2, 3, 2, 1, -2 and 1, right? We started with the degree 3, so that means we should have 4 numbers, 1, 2, 3, 4. Okay, let's just go ahead and do this. So it's 2, half of 2 is 1, that's a 3, then that's 3 halves. Okay, so that's like 1.5 minus 2 is going to be a -1/2. That's going to give us a -1/4. We're going to finish with 3/4. Okay, let me think. Yeah, we can do that. So we started with the degree 3, now we're at a degree 2, 1, like that. Okay, let's go with this. 2, 3. Okay. 2x squared plus 3x minus, what was it, a half? And the remainder. Okay. Did I check Zoom? I think I did. Let me just check one more time. Let me get this student. Got him. Let me stop sharing. Let me see. 11 and 12. Okay, sure. Let's make our way through 11 and 12. Screen. Show. All right. So let's move this like there. That's fine. 11. What number is this? It's 8. It's 10. So we'll start with 11. Find K such that this has, now, if you want me to do yours specifically, I can do it, or I can work this one right now. I'll go ahead and do this one since it's available. But like, if you want me to work yours specifically, if you click on the Ask My Instructor, it'll send me a screenshot of your question, and I'll pull it up now, and we can do yours specifically. And just say, hey, Mr. Pfeiffer, can we, I sent you Ask My Instructor, can we do that one? Let's see. Let me see. That might be enough space. We're gonna go with it. Okay. All right. Like this. So we're asked to find a K such that this has, okay. So I feel like the simplest way to go about this is synthetic division. You work it like normal, just try to adjust for that variable, right? So if x minus 5 is going to be a factor, that means our remainder should be 0. Okay. So that means in the chair, we're going to put 5. Okay. Now we write our coefficients, which are going to be 1. We got negative k, and 15. Notice I'm doing the same steps I would do regularly, just, just do the k, right? Okay, let's see. So let's keep going. The 1 comes down. That's a 5. So then that's going to become 5 minus k. If we multiply, that's going to give us 25 minus 5k. If we add those, that's going to be 25 minus 4k. Okay. We multiply by 5. 125 minus 20k. And then if we add those, let's see, 35, 40. 140 minus 20k. And that should be our remainder. But again, if we want x minus 5 to be a factor, our remainder needs to equal 0. So in other words, this 140 minus 20k needs to equal 0. You add 20 to both sides, you're going to get your 20k equals 140. Divide both sides by 20, k equals what, 7? Hopefully that made sense. But notice I kind of did the same steps as I normally did, and I just kind of adjusted for. I just took that. I didn't like try to find the answer. I just kept going as far as I could go, doing what we were already doing. Let me see my battery. Okay. So we got that K is 7. So, now we can check it. Like if we plug in 7, if we let K be 7, and then plug in when X is 5, the answer should be 0. Yeah, let's check it really quickly before we submit it, since we can. So what I'm gonna do, I need a new, like this. I think we're okay. Go ahead and do this. Thank you. Okay, and let me just reload and refresh. Okay. So now, if I go to my y equals and I put, let me see, x hat 3 minus is what, w? Now we said k was 7, so then that would be 7x squared plus this, I can do it over here, plus 7x plus 15, okay? X to the power 3 minus 7x squared, I definitely see a typo, plus 7x, and that's supposed to be plus 15, plus 15. Okay. So then now if I just call on that function and let x be 5, the output should be 0. All right, that's about the best we can do there. So we said k was 7. Let me see, now I gotta find. Okay, let's do this. Full screen. And I want this. Yeah, like that. Cool. You can. Okay, so we got that k equals 7. Hopefully that made sense. I'm here if you have questions. Okay, let's go ahead and move on to the next one, because I know there was a question number 12 as well. Let's see. I think it looks, is it similar? Oh, yeah, I think they're the same. All right, is it exactly the same? 23. Okay, I'm just gonna put 7. That was weird. Okay. Use the factor theorem. Might as well do this since we're here. Let me check on Zoom really quickly. Okay. So use the factor theorem to check whether this polynomial is a factor, the factor theorem. Okay. Find the remainder when this polynomial is divided by this. Let me see, is this a factor of this? Okay, so in order for x minus 2 to be a factor of that dividend, when we do synthetic division, the remainder should be 0, all right? Just for the sake of time, I think that I'm just gonna use my calculator, right? Actually, because after we do this, find the remainder when this, we're still gonna have to do synthetic division. But I mean, we can still just do that quickly in the calculator just to confirm. So then if we have negative, okay, 2x hat 3, nope, 2x hat, yeah, 2x cubed, okay, plus 6x squared, 6x hat 2, or actually I can just say I, okay, minus 8x, so minus 8x plus 10, okay. Looks decent. So then in order for x minus 2 to be a factor, that means 2 would have to be our 0. So I just want to call on that function and evaluate it when x is 2. Now I did not get a 0. Let me make sure I typed it in properly. negative 2x cubed plus 6x squared minus 8x plus 10. Since I did not get a 0, I would say no here, right? So that's why I felt like, well, let me do it on my calculator first instead of wasting my time trying to do it by hand. In case it was not a 0, we'll get a result quickly and we won't have to waste a lot of our time. Okay. What is the remainder when this first polynomial is divided by the second? Oh, I guess we still need to do that. Actually, the remainder is 2, right? We just evaluated it. Yeah, I think the remainder is just 2. That's from the remainder theorem. So when we basically, we took this linear binomial, this x minus 2. We took our a, which was 2 in this case. We passed it through the function. The remainder theorem says that f of a equals the remainder. So then when x was the remainder, instead of doing synthetic division, we got the f of 2 was 2, so that means the remainder was 2. So then we didn't have to, it was really just evaluate. They were just asking you to evaluate and interpret what the results that you're getting. Use the factor theorem to decide whether this is a factor. Okay, let's do the same thing, right? So we saw how quickly that can go, especially using a 83 plus, Okay, let's just go ahead and type this in. So we got 4x hat 4, okay, plus 6x cubed, 6x hat cubed minus 19x squared plus 88 plus 88x plus 14, okay? So then, again, I'm just gonna call on that function that I just typed in. If we want to decide if x plus 4 is a factor, then that means we need to evaluate it when x is negative 4, 0, right? If we did it right, we did not get a 0, so it's not a factor. Okay, and then our remainder, possible zeros. Okay, so this is the rational zero test, right? The rational zero test, if you take all the combinations of your factors of your constant term, which in this case is 1, divided by the factors of your leading coefficient, which in this case is 7. If this polynomial has any rational zeros, it's going to be somewhere in that list, all right? So we're doing all the combinations of 1 divided by all the combinations of the factors of 7. So, for instance, it can't be A because there's no 8, right? It can't be A or C. It can't be D. D is not correct either. It should just be B. Okay, let me kind of suppress this for now. Oh, that was it. Okay, cool. So they didn't even want us to actually find the zeros. They just wanted us to apply the rational zero test. I mean, I'm tempted to go back, but like these are good questions. Like I like these questions. All right. List the potential rational zeros of this function. Do not find the zeros. So then basically, again, you're doing the all combinations of the factors of the constant term, which is 1, divided by the factors of the leading coefficient, which is 5. So it can't be B, it can't be C, it can't be C or D because there's no 6 in the constant term and the leading coefficient. So it has to be A or B, but B isn't proper because if you're doing 1 divided by 5, you're not going to get 5, all right? So it has to be A. So that means what this is saying is that if this polynomial has any rational zeros, it's one of these 4. So if we wanted to actually find the zeros, we would start by checking these guys. We would start by checking these. If it's not these 4, it could still have zeros. It just might not be rational, right? It could also not have zeros, right? Because this is the degree of this polynomial is 4, which is even, which means our ends go off in the same direction. The leading coefficient is positive. So that means our graph is going to go up to the right. And because the degree of the polynomial is even, that means the other side does the exact same thing. So it's going to go up to the left. So potentially the middle might not cross the x-axis. It might not ever cross the x-axis. But, again, the rational zero test, all it's telling us is that if our polynomial has any rational zeros, it's going to be somewhere in that list, okay? Find the rational zeros here. This is a good question. We need to do this one. Let me see. What question number is this? 17. Okay, we're up there. So yeah, I don't mind doing this one because this one is more pertinent, or like more closely resembles questions that you need, that you're gonna like, that can pop up, that is specific to college algebra, right? So this is like a synthesis of all the different things that we've been talking about on finding zeros of polynomial. That's the whole point of this chapter, this thing here. Okay, let me just check on you guys in Zoom. Cool, you're looking good. All right. Thank you. I need you like there. Okay. So we're asked to find the zero. So we're gonna be invoking. Now there are other techniques. Oh, it's just dawned on me because we had to truncate a bunch of sections. There are some other techniques, like you only get them in college algebra, and I'm trying to think. I don't even know that we get them in college algebra too. Like it seems like they just been cut out. I mean, and it's not that it's pertinent, and not that I feel like cutting them out is the right move, because the average person does not really use this stuff, and the people that do use those hidden techniques, it would be brought to their attention, right? So it's kind of like the information is revealed as needed. If you don't need it, then why clutter your mind with things that you're not going to use, right? Well, it's a good chance that you wouldn't use it, right? So I think that was a good move to truncate that, because so many students for so many years are just having such a hard time with college algebra. So it's like, it's okay. It's trying to expand you, but we're not trying to shut you guys down. At least I'm not. But that's beyond me. Okay. So I'm just here to talk about the concepts. Okay. So find and like be organized and take notes and be a record keeper. But I'm not really doing anything. I'm just, hey, this person was here, they showed up, they submitted this at this time, based on whatever agreement that we had. That's all. I'm just a record keeper. I don't really do anything. I just crunch the numbers and, try to encourage you guys to do what you need to do to keep moving and to free yourself. Okay, find the rational zeros of this polynomial function. Okay. So a good place to start is the rational zero test. All right. So if we do our P over Q, so if we did our P over our Q, right? So the P's come from the factors of our constant term. So the factors of 15 are going to be plus or minus 1. There's no 2, but we can do 3. We can do 5, right? And I think that's 15. All right, I think those are all the factors of the constant term in this case. And then the factors of our leading coefficient are really just plus or minus 1. Okay, so we got fortunate in this one in that these are our possible rational zeros. Okay, because that leading coefficient is a 1, right? It just made it easy for us. Okay, so now these aren't the actual zeros. What we're saying is that if this polynomial has rational zeros, it's going to be somewhere in this list. So then the next thing is to find an actual zero. So it's always a good idea to test 1. You can use synthetic division, right? So if we do synthetic division using 1, if we take our coefficients, 1, 7, 7, negative 15, okay? Right, we started with the degree 3. We should have 4 numbers, so we don't need any placeholders. The 1 comes down, 1, 8, 8, 15, 15. Okay, so we got lucky. So that means that 1 is one of our zeros, okay? So since we started with the degree 3, at this stage, we're now at a degree 2. Okay, so let's write out the factors that we have. Now, we just found that 1 is a 0. So if 1 is a 0, then the factor is going to take on the form x minus 1. And we started with the degree 3. So now at this stage, we're left with x squared plus 8x plus 15. So then once you get it down to a quadratic, you can either just use a quadratic formula or just factor it, right? So I'm going to see if I can factor this guy. So I'm just going to bring down my x minus 1. And let me see if I can just jump straight to a factor form like this. X and x, it's going to be plus and plus. Two numbers that multiply to give us 15 and add to give us 8, 5 and 3. All right? 5 and 3. Because 5 times 3 is 15, 5 plus 3 is 8. Okay? So then, now that we have it in completely factored form, that means our zeros should be, I'm going to go -5, -3, and 1. Now, with something like this, we can check and make sure that these work in the original before we submit it. Like if this is our testing environment and we got a result like this, just plug it in, just plug it in. Like the ability to check is what made me fall in love with mathematics. It empowered me. It's like, even if the teacher didn't like me, they didn't have a choice. They had to give me my points so I can keep moving with my life. Okay, let's go like this. I just want to check these. Okay, and I want this one. Okay. Let's see. So then let me go to my y equals, and I'm going to type this guy in. We got our x hat 3 plus 7x squared. So 7x squared plus 7x minus 15. Okay. And I'm going to call on that function. And we want to test when x is -5, we got our 0. When x is -3, we get our 0. And when x is 1, we got our 0, right? So we confirmed that those three work. So now we want to hop back here, go full screen. Okay. And let me see, we got -5, -3, and 1. Let's go like this. So we got -5, -3, 1. Okay, that was an adventure. All right, that's why I went on and did this one. I started to go back to the beginning when I saw it. I was like, no, we need to do that one. Let's try to get one more similar to this, because these questions, these type of questions towards the end, they're basically a synthesis of all the concepts that we've been talking about. Notice we flowed from rational zero tests to synthetic division to the remainder theorem, to so many different concepts with one simple question, right? So that's why I was like, no, we need to definitely do this one. I'm grateful for whoever asked me to jump ahead, so that way we can get a little sample of some of these later questions. Let me go ahead and get a screenshot of this. This is going to be our last one for the day. Okay. But yeah, it's important. Like, I'm the authority on this. Like, nobody's going to be able to articulate it. I mean, maybe they can. I don't know. But no, if anybody should be able to articulate it, if you don't want to ask me, that's fine. I'm not going to twist your arm. But if I'm making myself available, you need to be like, you want to definitely get it from me, because I'm going to be the one touching the grade. Like, I should be the one that knows it amongst anybody, instead of having to go look for it. I mean, it's just I'm sitting there waiting for you guys. But that's neither here nor there. Let's go ahead and knock this out. So let's do the same thing again, right? Rational zero tests. P over Q. That's just a good place to start when trying to find zeros of polynomials, right? So is this a repeat? Because it's the same coefficients. I hope it's not. Let me check it really quickly. No, it's not exactly the same. Let's go ahead. Let's keep moving. So we kind of have the same setup with the rational zero. So we know it's going to be plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Okay. So this is the same argument as the previous, right? And so let's test when x is 1. 3, 2, 1, 0. Okay. So if we put 1 in our chair, our coefficients are 1, -9, 23, and -15. Okay. And having your professor, like, I don't know, having your professor answer questions like you know, I had professors that would not answer questions. And they just like they would kind of get mad, and it was just very weird. Like some of the professors, I mean, a lot of us, I think it's only human nature to kind of be in your ego. Lord knows I battle with it. But some professors, man, like I couldn't go to them. I would try and I couldn't. And like they just refused to help. But I did notice that if I was like an attractive female, they kind of responded to the females differently. But there was nothing I could do about that. So I was like, okay, well, I got to figure out how to do it on my own, figure something else out. One of my former students told me that if you're talking to somebody and they're not saying what you want to hear, you're talking to the wrong person. Just talk to somebody else. So, and that's been pretty accurate. Like that seems like that's been working. The one comes down, 1, -8, -8, 15. 15, God is good. We got lucky again because that's a 0, right? So if 1 is our 0, that means the factor takes on the form x minus 1, okay? If we started with the degree 3, that means at this stage we're now at the degree 2, right? It's called a depressed equation. So then we have this x squared, thank you. We have this x squared minus 8x plus 15, okay? Let's see, is it the same? It's nearly the same. There are some nuances that are different from this one and the previous, right? We got x and x. They're the same. They're both minus, and I think it's still 3 and 5, but the signs change. So now our zeros end up being 1, 3, and 5. Just for the sake of time, I'm just going to go ahead and submit these instead of checking it, just because we're essentially out of time. I'm confident in them, especially since we got like the same numbers just with different signs. I thought that was interesting. 1, 3, 5. Okay. 1, 3, 5. All right. All right, guys. Did you have are there any burning questions? Let me go ahead and let me at least go ahead and make a copy of the work that we worked on today. Let me go ahead and make a copy available that looks good. I'm going to send it. When this bar finishes loading, you'll get a copy of whatever you saw me writing. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.
Thank you, Professor.
My pleasure.